time that we'll be able to see it.
Yes, it's going from the far south. Now it's over the equator, and it will be heading straight north and going essentially near the North Pole. So now we will have the polars in the sky, and we'll have a chance to see it from the northern hemisphere now.
All right. The counter is 0. It has passed closest approach, and this asteroid is going away.
It's on its way out.
It's been here, done that.
But throughout the day, it'll be observed by observatories around the world, and we'll get a lot of good information on its spectral type, chemical composition possibly, spectrum of it, and the radar data will give us essential information on the shape and size and rotation.
What's very interesting is how much information you're getting from hobbyists, from amateurs. It's as though the more eyes are always better.
Yes, it's a worldwide effort, and astronomers around the world send in data on these asteroids, and they're all collected and all used in a combined solution to figure out its orbit.
All right, so
what's next? And there it went. We hit 225. It was a major, major moment in space history. Maybe you're sitting there thinking, okay, didn't see anything, didn't hear anything. Why is this such a big deal? Ed Lu, I want to bring you in. Astronaut Ed Lu, asteroid hunter Ed Lu. Help me understand, because from what I can tell, you're saying, look, this is a wake-up call. This is very, very serious. What kind of threats do asteroids provide?
Asteroids are a threat because they sometimes hit the Earth, as happened last night in Siberia. And 2012 DA14 is, as you said, a wake-up call. These things are out there. The risk is small on any given day, but eventually, if you play the odds long enough, we're going to get hit again. And the B612 Foundation realized that we don't have to sit there and take it. We can actually do something about that. There's a lot of misinformation out there that people that believe that you cannot deflect these asteroids. You can, but only if you have decades of notice. If you have a short notice like we have for 2012 DA14, not a lot you can do. We would have been just evacuating an area if this one was to have hit, which it obviously didn't.
Let me just back up.
The next one.
Can I just back up? Here's my question. Where does an asteroid come from now that it's, whizzed past us? Where does it go?
Well, these things are orbiting the sun. The asteroids going around the sun just like the Earth. So they go round and round and round. And some of these asteroids, their orbits actually intersect Earth's orbit. That means someday there's going to be a collision because they're pass across. It's like those old demolition derbies you may have seen in county fairs.
Yeah.
With the two cars going around different tracks. If they show up at the same place at the same time, there's an impact. But we can predict those ahead of time if we put a space telescope out into space and just map the locations of all these. We can do that.
Do we have a space telescope? Is that part of why you're an asteroid hunter? Because you want to raise awareness, you want to make sure we aren't on some collision course, we aren't like those cars that you were describing? What do we do?
Well, we are building a space telescope and it's launching in 2018. So the pieces are coming together right now. The beginning parts of it are being produced in Boulder, Colorado, but the B612 Foundation is doing this as a private organization because we realized that we could actually do it. And there was two things we could have done. We could have waited around, worried about why isn't somebody doing something about this, or we could just do it ourselves. And we've assembled a team and we have gathered supporters and we're making it happen.
Ed, we were talking earlier, and I want to bring Chad Myers in as well, our meteorologist, and Chad and I were talking earlier about this meteor, right, which is different from an asteroid. This meteor over Russia that sort of rained down on all these people, injured about 1,000 people. Is it really merely a coincidence that these two things happen on the same day? They're not at all related?
It sure seems to be. It came from a different direction, and it came many hours before 2012 DA14, so it doesn't appear to be related. And yet another sort of warning to us that, hey, you know what? These things do hit the Earth. And the next one that hits may not be so small.
Okay, Ed Lu, stand by for me. I want to bring Tom Foreman back in for more of an explainer on, again, what this looks like. Tom, what do you have?
Well, when you're talking about there, Brooke, we're talking about the impact of these things. This is something that's worth talking about. If you've ever been out to Arizona to Flagstaff, there's a big place out there called the Meteor Crater. I want to talk about that in a moment. But first of all, think about where this thing hit. It hit up here in Russia, and a lot of people have been asking, how do we know it's not connected to the asteroid that just passed minutes ago? This meteor meteoroid, right? Which way you want to describe the impact on the Earth. And in fact, the reason we know is because of the way it hit. This hit up here. The one that just passed us, or is passing us as we speak, because it'll still be in the Earth-Moon system for some time now, but basically under the Earth here. It came sweeping by. Simply the direction it went suggested that it's not coming from the same direction. So that's one of the reasons we know. But I want to get back to this question of the meteor crater, because this is important. You know, the Russian meteor that hit earlier today, or exploded earlier today, and then parts of it hit the Earth, that was about 10 tons, 10 feet in size, we think, traveling about 33,000 miles an hour. And you see what happened when it exploded, when all the gases inside of it blew up in the atmosphere with all that speed. It created all this damage here. 1,000 people injured, 270 buildings damaged. But this one was by size, physical size, about the same as the one that created the meteor crater in Arizona a long time ago. The difference being that the one that created that meteor crater seemed to have a lot more iron and nickel in it, so it's probably about twice as heavy. That's the estimate. But here's one really interesting fact about this. We really didn't have proof until 1960 that this was the result of a meteorite, actually, the way it hit Earth. People for a long time thought this was a volcano that had caused this. But then in 1960, a scientist essentially said, no, this really was an impact on Earth. Think about it. If you walked around the rim of this brook, you'd cover more than 3/4 of a mile. And that has survived all this time. Think about the power it takes to create that impact. That was created by something about the size of what hit Russia, or what exploded over Russia.
Overnight.
And it weighed more, but still, that's what you get from that. So you can imagine, this was a tiny, tiny thing compared to the asteroid we were just talking about, which brings us to that question of, if in fact we were hit by something as big as what just passed, that would be a big event.
Well, when you think about it, you know, it wiped out the dinosaurs apparently. That was something like 6 miles wide, and this thing was just the size of a New York City apartment. So there are differences, and as we've learned today, Space 101, you have the asteroid, which is the rock in space. You have the meteor, which breaks off of the asteroid, and that's what comes through the Earth's atmosphere, and the meteorite is what breaks off the meteor and hits Earth. Tom Foreman, I thank you very much. Ed Lou, we're going to come back to Ed next hour. But that's your asteroid that whizzed past Earth here in the last couple of minutes. Coming up, though, I have a special guest. Let's get the jib shot. Special guest here.